Welcome to section 1-2, extra practice problems. The work that we're doing here is going to be multi-step or two-step and then build to multi-step. Solving for variables where multiple things are happening to the variable. When we see this problem, the first thing we want to do is get rid of the addition and subtraction. So we're going to need to subtract 4 from both sides. That cancels it out. That gives us 4 equals t over -3. T is being divided by -3, so the inverse of dividing by -3 is multiplying by -3. That 3 in the numerator, -3 in the numerator cancels with that -3 in the denominator. We get -12 equals t. We're going to check our solution. 8 equals, we're going to substitute -12 in for t and simplify this right side. Left side's already simplified, so we don't need to do anything more to the left side. This gives us 4 plus 4, and let's simplify completely. And yes, 8 equals 8, so we know that our solution is correct. Now, this is a little bit different. This is a vinculum. So we see that the variable and a constant is in the numerator. That is not, there's a couple things that you need to understand. This is not this, but you need to understand that p plus 5 over 2 is just like p plus 5 quantity divided by 2. And that this is really, that 2 is underneath the p and the 5. So if we were going to string it out, we would have p over 2 plus 5 over 2. That's what this is equivalent to. That's not, not a lot of students know that. And so that's very important that we see that. And it's sort of like distributing that division into each of the things. So not that this helps, it's just this is all concept. You need to understand the conceptual aspect of what this statement means. So we can't get rid of, and let's get rid of this. Speaking of getting rid, let's just get rid of this so we can write. So I can't get rid of that 5, that plus 5 yet. You cannot subtract 5 because, as we see over here, there is no 5. That's not 5, that's 5 over 2, and we wouldn't subtract 5 over 2 either. What we have to do in this specific example, very rare example, is we have to get rid of this denominator first. This dividing by 2. So we're going to get rid of the dividing by 2 first. And that will cancel. You're left with p plus 5. Now you have it. Equals 18 minus 5 minus 5. P equals -23. So you have to be able to see the difference between problem number 1 and problem number 2. Here, the variable is 4 is being added to it, and it's being divided by -3. Here, we have this vinculum, and we have this quantity. This is a quantity. So we can't get to the p and the plus 5 until we get rid of that -2. Sometimes we need to simplify. We have like terms, so it's important that we simplify each of the sides before isolating. Now we can divide by 5, and we get k equals 12. We couldn't simplify here because p and 5 aren't like terms, and we can't simplify here because t over -3 is really -1/3 t. That's another concept that you need to understand. Okay? So lots of good little nuances, innuendos that you have to be aware of. We're going to combine like terms first. If we can simplify, simplify. We can't simplify these because they're on opposite sides of the equal sign. But we can simplify these because they're like terms and they're on the same side of the equation. Now we want to get rid of the 12. This is a positive 12. This negative right here is attached to the 5p. So we want to get rid of the positive 12. We're going to do that by subtracting 12. That gives us negative 55 equals negative 5p. Don't forget that negative that's attached to the 5p. We'll divide by negative 5, excuse me, and we get 11 equals p. We can combine like terms. Like terms have the same variable to the same exponent. 28 equals 21b minus 35. We're going to now get rid of the addition and subtraction first. That gives me 63 equals 21b. Divide by 21. And we get 3 equals b. We should be able to see that 21 times 3 equals 63. That's mental math right there. Again, simplify, because these two variables are on the same side of this equal sign. They are like terms. That's going to give me negative 8j minus 6 equals negative 30. Let's add 6 to both sides. Negative 8j equals negative 24. Divide by negative 8. Divide by negative 8. J equals 3. Two negatives divided make a positive. A bill to landscape your yard is $720. The materials cost $375, and the labor is $34.50 per hour. Write and solve an equation to find the number of hours of labor spent landscaping your yard. So we want to find the number of hours. Okay, so we have a bill that is $720. So this is my bill is going to equal the materials plus the labor. And labor is going to be, the labor, L is the number of hours times the cost per hour. So that's how we do that. So we have this material cost, $375, and then we are charged $34.50 per hour. So for every hour I have to pay $34.50 for the work to be done, and then I also have the $357 as my material cost, and that total will equal $720. So it looks very similar to the first 6 problems. We're going to subtract 357. That's 3, that's 6, that's 6, that's 3 equals 34.5h. We can take the 0 off now. That 0 isn't really helping us. We can divide by 34.5, 34.5, and for efficiency purposes, and because I know you're going to be at home doing these problems, and we will be able to use calculators, but there's going to be times where I'm going to ask you to do this this physically on your paper, but for today, and there are opportunities, we will be utilizing a calculator. 34.5. So that doesn't make sense. Let's see if I made a mistake somewhere. So 720, I knew I made a mistake. So do you see that number was a crazy number, and that was going to represent the number of hours. And so that wasn't a clean number. Not to say that we can't get crazy answers, but when we get a crazy answer, let's stop, let's check our work, and make sure that we didn't make any mistakes. And I already see my mistake. 375, and you must have been, hey, Mr. Mack, why are we doing 357? That's called dyslexia, kids. Mr. Mack has dyslexia, so he reverses things every now and then. So let's try this again. Let's redo this. Sorry, but nobody's perfect. 375 and 720, and we're going to subtract 375, subtract 375. We're going to still borrow, that's 5. We're going to borrow, that's 6, that's 4, and 3. Oh, I can do that. I don't need a calculator for that one. There you go. So that goes in 10 times. Oh, Mr. Mac. So the question says, write and solve an equation to find the number of hours of labor spent landscaping. A bill. So the landscaper, we're going to make a sentence, a word sentence. When you have a word problem, you have a word solution. The landscaper worked 10 hours. You can leave it at that. The landscaper worked 10 hours. And you have to include the 10 hours because that tells me you understand what you found. In exercises 8 through 11, solve the equation, check your solution. So a lot of students are going to want to do subtraction first, but you can't. Orders of operation tells you that you have to do multiplication. We can't combine these, those are unlike terms, so we actually have to distribute. And what are we distributing? We are not distributing 5, we're distributing -5. -5 needs to be distributed. That's going to be my first step. That 12 minus 5 times 3r minus 5 times 2. We're distributing -5 to 3r and +2. So we better see 3r and +2, and I need to see -5 being distributed. And so now we're going to simplify those products. This is still multiplication. So that gives me -15r. This gives me -10 equals 17. I'm not going to move things. I'm going to make sure that I am simplifying prior to moving things. So that leaves me with -15r plus 2 equals 17 minus 2. Now this is a two-step, and we get -15 divided by -15, r equals -1. Really good problem. Most students are going to make their mistake and do 12 minus 5 and distribute the 7. Big problem. Not what you should be doing. Love that problem. Same thing, we can't combine inside the parentheses. We can't simplify in that manner. We will distribute the 3 into that parenthesis, and we will distribute the 5 into this parenthesis. So we get 3 times x plus 3 times -2 plus 5 times 2 plus 5 times -x equals 16. That gives me 3x minus 6 plus 10 minus 5x equals 16. Let's combine like terms. We've got like terms here also. We have 2 pairs of like terms. 3x and -5x is -2x. -6 and +10 is +4 equals 16. Let's subtract 4. That gives us 2x equals 12. -2x, -2, x equals -6. We can't combine anything inside the parentheses, so we will distribute each of those parentheses into each of the parentheses. 3 equals -1 times v, -1 times -4, +4 times 2v, +4 times -9. 3 equals -v plus 4 plus 8v minus 36. Combine like terms, -v and 8v, positive 4, and negative 36. 3 equals 7v minus 32. Let's add 32. Add 32, getting rid of the addition and subtraction first. We get 35 equals 7v, divide by 7, 5 equals v. Number 11, still can't simplify inside the parentheses. We're going to distribute the 6 into that parenthesis. We're going to distribute the negative 3 into the parenthesis. 6 times q plus 6 times negative 7. Remember that negative stays with the number it's attached to. Minus 3 times 4 minus 3 times negative q equals 0. 6q minus 42 minus 12 plus 3q equals 0. Like terms, you get 9q minus 54 equals 0. Add 54, 9q equals 54, divide by 9, q equals, not 5, 6. Woo, that was close. Q equals 6. Write and solve an equation to find the number. So first we have to translate this sentence, 7 plus the quotient. 7 plus the quotient, that's division of a number and 5 is negative 12. So 7 plus the quotient of a number and 5. So the quotient of a number, we'll say n, quotient is division, and then we're going to add 7 to it, is negative 12. So that's how I'm going to do that. Quotient of a number and 5 is negative 12. Yep, so let's subtract 7 first. We get n over 5 equals negative 19. We're going to multiply both sides by 5. And that leaves me with n equals, that's negative 95. Yeah, negative 95. The difference of 3 times a number and half the number is 60. So the difference of 3 times a number and half the number is 60. So the difference, that's subtraction of 3 times a number minus half the number, we can write that like that, is 60. Ooh, that's a good one. All right, I may even write this half the number, minus half the number. So I'm going to find, these are like terms, so I'm going to simplify them, but I need a common denominator. So I need to be in halves. So, 6 halves is equal to 3, minus 1 half n equals 60. So I'm going to make sure that I can simplify those two. That gives me 5 halves n equals 60. And the inverse of multiplying by a fraction is multiplying by the reciprocal, because these cancel and you're left with n. That's how you get the value of 1. 5's in the denominator, 60's in the numerator, that's 12. So we get 24. Don't make that 120 over 5 and then simplify. Use cross canceling. It will help you. 8 times the difference of a number and 3 is 40. So 8 times the difference, well, that's a quantity, and the difference of a number and 3, we're taking the difference of a number and 3, and we're going to multiply that by 8 times. So this is going to be first. We have to do the difference of a number and minus 3, and then get 8 times that. So we're going to do this. There's a couple ways to do this problem at this point. So I'll show you one way, I'll show you both ways. But in this case, I see that I can do it. So we can't simplify inside the parentheses, so we're going to distribute. So we would get 8 times n plus 8 times negative 3 equals 40. We get 8n minus 24 equals 40. We'll add 24, 8n equals 64. Divide by 8, n equals 8. That's one way of doing it. Here, we can actually, because we can't get into this variable, we need to get rid of that. So we can divide by 8 here. And that leaves me with n minus 3 equals 5. And then we add 3, and we get n equals 8. That's the high school way to do that. That is probably new to some of you. And that's a really efficient way to do this specific problem. You can't always do it. It works because these two are factors. They have a common factor of each other. If this was 7, I wouldn't choose to do it in that manner. Well, I would, but it'd be a little bit more complex. Justify each step of the solution. So we write the equation. This is distributive property. Then this is multiplication. All we did was multiply. We multiplied. Then we simplified. We combined like terms. We combined 7 and 20 to make 27. We did the addition inverse. And we did the addition inverse because we subtracted 27 from both sides. And then we did the multiplication inverse. We divided both sides by -2. Solve the equation using two different methods. Which method do you prefer? Okay. -2 equals 12 plus 4 times the quantity 2x plus 7 plus 6. So one way we can do this is we can simplify these two like terms. You can get -2 equals 18 plus 4 times the quantity 2x plus 7. We could subtract 18 from both sides. Gives me -20 equals 4 times the quantity 2x plus 7. We can divide by 4. That gives me -5 equals 2x plus 7. We can subtract 7. We get -12 equals 2x. Divide by 2, and we get -6 equals x. That's going to be how a high school student does that problem. Let's see how a 8th grader might choose to do this problem. I still would combine these like terms. I would do -2 equals 18 plus 4 times the quantity 2x plus 7. I cannot add that because this is multiplication. We don't add before multiplication, but I'm going to distribute this. So I get -2 equals 18 plus 4 times 2x plus 4 times 7. That gives me -2 equals 18 plus 8x plus 28. And now I'm going to combine these two because they're on the same side. -2 equals 8x plus 46. I'm going to subtract 46. I get -48 equals 8x. And now I'm going to divide by 8. And I get -6 equals x. Same answer, two different ways. Find 3 consecutive odd integers that have the same sum of -51. Explain your reasoning. So 3 consecutive odd integers. So an example would be 3, 5, and 7. And we notice that each one is 2 away. Consecutive odd integers are always going to be 2 away from each other. So if x represents the first odd, my next odd would have to be x plus 2 would be my second odd, and x plus 4 would be my third odd. So this represents each of my numbers. X is my first odd, x plus 2 is my next odd number, and x plus 4 is my third. Think about it. If x equals, if this is my first, 3 plus 2, if I plug that in there, 3 plus 2 is 5, and 3 plus 4 is 7. So it would produce the proper values. So if I'm going to add them up, I'm going to have x plus 2 plus x plus 4, and that sum equals negative 51, well, that equation should be able to tell me what my x is. So I'm going to combine like terms. That's 3x. I'm going to combine like terms. Plus 6 equals negative 51. And now it's a nice simple two-step. Get rid of the addition and subtraction first. I'm going to divide by 3, and we get x equals negative 19? Yeah, negative 19. That is my first odd number. So this is negative 19. And then if I want to find my next one, I'm going to do negative 19 plus 2, which is negative 17. And I'm going to do negative 19 plus 4, which is negative 15. So my three consecutive integers, odd integers, are negative 19, negative 17, and negative 15. If I add those together, 19 negative plus 17 negative plus 15 negative equals negative 51. Pretty cool, right? All right, those are the solutions. Hopefully those coincide with all of the things that I have been showing you. Oh, that's interesting. N plus 2, N plus 4, N plus 6. That's interesting. I don't know why they would start off with N plus 2, but I like mine. You all have a lovely day. Good luck.